All right, class. So this lesson, we're going to start Unit 3, and this is Lesson 1. And Unit 3, we're going to learn how to graph quadratic functions. Okay? Unit 3, Lesson 1, graphing quadratic equations or functions. Okay, let's look at the characteristics of a quadratic function. A quadratic function is any function that is in the form, and I'll just write it here, ax squared plus bx plus c. The most important part on this will be the square. Your highest exponent is you have an x squared. All right, so, and then when you graph a quadratic function, it looks, you'll get this U-shaped, and this U-shape actually has a name. We call it a parabola. Okay, so when I say, when I ask you anything about a parabola, you know I'm talking about the graph of a quadratic function. And how do you know it's a quadratic function? It's in the form ax squared plus bx plus c. Most importantly, it'll have x squared. So this is the one in the blue is the parabola I'm looking at, and I'm just gonna write a few things about it. So right here, the dotted line, right here, we call it the line of symmetry. Because a quadratic function is symmetrical, the left side will always be equal to the right side. For example, if I were to fold the graph over on the line of symmetry, it will be right on itself over here. So it's symmetrical on both sides, and the graph of a quadratic function, these two things here that I have at -1 and 3, we call them x-intercepts, because it crosses the x-axis. Okay, I will probably type that. Hang on. Okay, they're called x-intercepts. Sometimes they're called zeros of functions. Sometimes we call them solutions. There's another name I'm going to write. Sometimes we call them roots. Okay, and when we see that roots, you won't, maybe, well, let me just leave it at that. Okay. Oh, that's where I have all these arrows. Okay, so these are the x-intercepts. Sometimes we call them zeros. Sometimes we call them roots. Sometimes we call them solutions. Okay. What else? Right here, it's crossing the y-axis, so we call this the y-intercept. And it really doesn't have any other names, but some y-intercept is where your x is equal to 0. Okay. And then right here, this point, right in the middle of the parabola, this is an important point. We call it the vertex. So when we have a quadratic function written in standard form, a quadratic function written in standard form, it looks something like this. F of x equals a parentheses x minus h parentheses squared. So this is what makes it a quadratic. Your x is being squared. You can have, the x can have a number attached to it or not, but x squared is what makes it a quadratic, and you have plus k. A, h, and k are all constants, and this is what they represent. If the number that's attached to the x, it could either be subtracted to x or added to x. We call that, and then the k, we take those two numbers, and that will be the coordinate for your vertex. It's the vertex. And if A is greater than 0, meaning this number right here, if it's positive, it opens up, something like this. The parabola, the U shape, opens up. And if A is less than 0, if A is negative, it opens down. Okay, it looks something like this. And the vertex is if it opens down, something like this, and this vertex right here, we call it a maximum point. And then if it opens up, and this point right here, we call it a minimum point. Also, the H, this number, tells you to move left or right. We call that the horizontal shift. And the K, this number right here that's not with the X, it tells you to move up or down. We call that the vertical shift. Okay, we're going to go through some examples. Here's an example. F of x is equal to x squared. This is actually called the parent function because we don't have any other numbers except for just x squared. This is how the parent function looks. So we're going to graph it. Actually, I have my Desmos up. Y equals x squared. There you go. There's your function. Okay. It looks something like this. Let me try. Now, depending on what your H, K, A are, that's what changes the parent function. From this parabola, well, my ugly looking parabola here, and depending on the A, H, and X, we change how the parabola looks. And here, if you notice, the vertex is right here at 0, 0, and this has a minimum because it's at the bottom here. The horizontal shift is 0 units. It's not moving anywhere. The vertical shift is 0 units. It's not going up or down. It's just staying put from 0. The range here is actually, it starts at 0 and goes up. So we can say the range, which is on the y-axis, is greater or equal to 0. Okay, it's going up. The zeros of a function, in other words, the x-intercept, it only has one x-intercept, is touching the x-axis at 0, 0. The parent function is kind of boring. Increasing, decreasing, where is the function increasing? Well, it's increasing right here from 0, x equals 0 to positive infinity, and it's decreasing from negative infinity to 0. Okay? So it is increasing from 0, x is between 0 and positive infinity. It means it's increasing from 0 and up, 0 and to the right, I mean. And then decreasing from negative infinity, x is between negative infinity and 0. Okay? Let's go to some better examples. Here is my function in standard form. Let me graph it. X minus 3 squared plus 1. X minus 3 plus 1. So it took the parent function, it looks like it moved it to the right and up, and it's still facing up. So I move it to the right 3 units. There's your vertex. I can click on it. 3, 1. There's your 3. And there's your 1. Okay, if it's negative 3, your x-coordinate will be positive 3. And then your y-coordinate, it stays the same as what it is. Okay? All right, so let me write that down. The vertex is at 3, 1. Oh, gosh. Let me try to graph this again. I'm going to try my best here. It's not too bad. Here's your vertex. 3, 1. This has a minimum. So I always have to think about this twice because it's here at the bottom. This has a horizontal shift and move to the right 3. So I'm just going to say that. I'm just going to say right 3 units. And it has a vertical shift of up. So this is up 1 unit. The range of this function is, it starts at y equals 1 and goes to positive infinity. So we can say y is between 1 and positive infinity. Zeros of a function, x-intercepts, no x-intercepts. I don't know if you remember from unit 2, but we can say that the zeros are imaginary zeros. Okay, but we really won't get into that right now. And then increasing intervals is the same. It's increasing from x equals 3 to, so x is between 3 and positive infinity. So it's increasing from 3 to positive infinity, and then it's decreasing from negative infinity. X is between negative infinity and 3. Okay. And 2 more examples. Here, let me see if I can do this without graphing. So this doesn't have a k here, so I can just say plus 0. I'm not really changing anything if I say plus 0, which means that my vertex must be 4, 0. Okay, let me graph this. Negative x plus 4 to the square. Negative x plus 4 squared. Oh, look at that. It opened down because of the negative here. Okay, and my vertex, let me click on it. Negative 4, 0. Is that what I said? I didn't say that. I said positive. Because I saw the positive 4, but just remember that you have to take the opposite sign. I did not do that on purpose. That was an honest mistake. So it looks like this. It opens down, which means that it has a maximum point. This has a horizontal shift of 4 units to the left and 0 units down, or no vertical shift. Okay, 0 units, neither up or down. The range is, I love looking at the range of quadratics. The range is y is less than 0. Okay, everything is less than the y-axis is less than 0. The zeros of a function, where does it cross the x-axis? It crosses it at, or it touches the x-axis at negative 4. That is your 0. Okay, hang on, let me check one thing here. Is that what I said here? The first one for the parent function. Okay, sorry. It's 0 of a function, you don't write it as a coordinate, you just want the x coordinate, which was at x equals 0. That is the x-intercept. Okay, don't give it a, you can give it as a coordinate, but yeah. Or the x-intercept is at 0, 0. No x-intercepts. Here, the x-intercept is x equals negative 4, or we can say it's negative 4 and your y-coordinate will be 0. Always for x-intercept, your y-coordinate will be always be 0, and that's why it's called zeros of a function. And here's the last example. 1/2 x squared plus 3. Let me see. The vertex here will be, it's negative 0. There's nothing here, so I'm going to put 0 for x. Well, there's no such thing as negative 0. It's just 0. And then your y, or your k, is 3. I better graph it. So 1/2 x squared plus 3. 1/2 x squared. Did it have parentheses? Yeah, it did. X squared plus 3. Let me look at that. It the vertex here is 0, 3. Hey, I was right. And then and it opened up because it's the A here, the number in the front is positive. That's another ugly graph. Anyway, it has a minimum. And the horizontal shift, it doesn't have a horizontal shift. I'm just horizontal shift. I can just put none or not applicable, or I'm just gonna put none. There is a vertical shift. It moves up 3 units. It's at the bell. All right, the zeros of the function is none. There's no zeros of a function. The range is y is greater than 3. Sorry, that's the music started. It's increasing from y is between 0 and positive infinity. It's increasing here. And then it's decreasing from negative infinity to 0. Okay, it's decreasing here until 0. X equals 0. Oh, sorry, this should say x. Remember, increasing and decreasing, we only like to look at x and x-axis. All right, thanks.